Next piece in line for the build, the ram casting. Let's take a look. Ram casting initially appears to be very clean. We've got some draft on the side. There may be a little bit of warp in the bottom, yet to be seen. I haven't touched this piece, no filing yet, but that is exactly what I'm going to do when I start this. I'm going to establish a flat bottom either with emery or a file or whatever means necessary, and then I'm going to bank it against the back jaw, establish two flat rails, reflip it, machine it flat, and then we're going to get into centering everything up. Chances are with a pin against that edge right there. Let's pop this thing over. Actually, we're not going to put it on the machine yet. We're going to start with a file on the back side, clean it up, and see what we're starting with. Let's do it. Let's get a little fussy here for a second. You just saw me lay the pin on this casting and indicate the casting in the machine to make sure that these surfaces are not only true to the elevation, but parallel to each other. Now that does not mean that it's true to the part. It doesn't mean it's central. So we're going to do basically the same thing in reverse. And watch the needle on the indicator. I'm going to lay the pin right in between the two draft surfaces because that's a solid registration point. And we're about +1. Okay, call it 0. And flip it over and do the same thing on the other side. Okay, we're about +9 on that side, which means this pin is 9 thousandths higher in this orientation. So that means 9 thousandths got to come off of this side right here. Pop it back in the machine. We'll come right back, double check it, look for symmetry. Then we'll go for size. Single dust cut taken. Let's take another look. This is, I am sure, overkill for what it does. We got a 0 on that one. But I like to make sure that it is probably as good as it can get. There you go. These two sides are now parallel. They are now true to the remainder of the casting and can be brought into size accordingly. Let's do it. Let's talk about order of operations here for a second. This was put back in the machine and cleaned up exactly the same way you saw me initially dust these sides. Pressed against the back jaw, single pointer in the center, and it was brought down to the dimension on the print. Once it was brought down to the dimension on the print, I want it parallel this way as well. So the only surface I have that I'm going to trust would be this top surface right here. The part was inverted, banked on a parallel right there, and decked off. Now, according to the print, there is a dimension right here of 406, 1332 imperial. And that is the number I shot for in the middle. We're a couple of tenths under, but there's a draft on this surface, so one end is about 2 thousandths high, one is about 2 thousandths low. But the parallel part is right here. That's what I was looking for. This serves no purpose whatsoever. Now the outside of this part does need to get narrowed down. If I can do this without totally screwing it up. Like this. There's an edge cut on both sides. Like that. Now when I do that, I'm going to lose a lot of my banking material off of the side here and risk cracking it, squishing it, whatever. So I'm going to do all the slot work on top. I'm going to do the slot work on the bottom, the holes from the back, possibly interpolate the front. This seems to be completely round, and I'm going to do that by back boring it. Use a boring bar with the bar turned around, and I don't know if you've ever seen that, but that's pretty cool. Then once it's on center for having backbored the outer diameter, I can then do the hole work in the center because the machine will already be on location. So there you go. That being said, let's pull the cutters out for the slot work. These guys here and the ones on the bottom. We'll do those first. Let's do it. All right, after taking a second look at the print, I've noticed that most of the slot work on the top and the bottom is dimensioned from finished ends and finished lengths. So that's got to be the starting point. First place we're going to start here is just dust this end off until it's nice and square, and I'll stand it up and bring in the overall length, the thickness, and the diameter, and the bore. That's the new plan. Always pays to look twice. Look twice, cut once. Next operation on this piece, I need to stand this piece vertically as such. Now I'm sure there's a dozen different ways to do this, but I'm going to choose the one that I'm most comfortable with. Since you can see the way this piece is configured on the back side, several steps in there, well, you want as much contact as possible in the center, and that's down here. But all the work is being done up here. So chances are this is going to want to jump around, not like that, of course, but it's going to see some noise, it's going to see some vibration. So you have two choices here. You can change over your jaws. You have a bunch of choices, but these are my choices. You can change the jaw over to a taller jaw, which is what I'm going to do. I'm fortunate enough to have several sets of those. Or if you need just a little bit of room, you can take the jaw off, reverse it, and put it back on. You can see that the pattern of the holes is asymmetrical, and when you do that, you pick up about 3/16 of an inch underneath the jaw. You do lose the parallel relationship between the top of the jaw and the body, but you will get the extra room you need if that's not important. And as far as taking these things off, little shop gem for you coming up right here. Boom, broken 3/8 Allen key. I saw this thing off years ago, and I can just stick that in there and just spin it with my fingers instead of trying to get the awkward angled Allen key down in there if you don't have a ball and Allen key. This works like a charm. Put one of those in your toolbox. All right, let me change it over to Big Jaws and we'll get this going. This is the setup that I'm going to be using for both end operations, and I think you can see the benefit of that. My vertical reference surface is a 1-2-3 block held in place with an extremely heavy spring, so light pressure is not going to move that block. This setup lends itself perfectly to another little nifty that I like to include once in a while. And every so often you're going to do a setup that you need to hold a piece, hold a block, hold something, and you need 3 hands, and you just can't tighten the vise. Now, if you're like me, you've taken the big heavy handle off of your vise and you've got one of these speed handles. Hopefully with all 3 arms still intact. But this is my one-handed speed handle. Anyway, what I'm about to show you is a trick that I use an awful lot here. And when you need that 3rd hand, that extra handle that you just put on the shelf comes in real handy. Snug down the setup to the point where it's in place. Okay, everything is in place. It doesn't have to be perfectly positioned, just in place. Take that handle off and go get your other one. Put that on there and clock it to around 4 o'clock. And when I say that, I mean if this was a clock, there's 4 o'clock right there, right? Or maybe lower if it'll still hang. Yeah, it's a little questionable right there. Go where it hangs solid, where there's no more give. And when you do this, make sure that your handle is not going to encounter any part of the machine when you swing it down. This is going to be a little hard to do, but let me see if I can lift this up. Let me get this on the tripod so I can show you exactly what I'm doing. This is a good one to know. All right, this should be it. Balance your handle now in the vertical position. The vise is now open beyond where it should be because we know 4 o'clock is locked. So right now this is just sitting here, just balanced. I'm going to put both my fingers in here, and I'm going to nudge this with the inside of my left arm. One hand on the V block, or one hand on the 1-2-3 block, one hand on the part, and here comes the elbow. Oop. When it falls down to the 4 o'clock position, it locks the part in place. So now that it's down here, you can snug it up, you can take it off, whatever. But by hitting the handle with the inside of your elbow, forcing it down, there you go. You now got your 3rd hand for free. Let's indicate the center of this particular part. I'm going to edge fine left and right and the back, and we're going to make this round. The boring head is now set up with the boring bar facing towards the center of the boring head. Now, this is a very good reason for this, because this is an OD cutting operation. And there's the OD that we're going to cut. As this tool comes around, it'll track a little bit on the front after a bit, but it's going to hit these back 2 corners first, and that's where I'm going to set my depth. The depth on the print is given from this face down to these shoulders, and that is what I will attempt to establish. As you can see, this is a DBL 202 Criterion boring bar, and it's tagged as Costa Mesa, California, so for everybody out there in Costa Mesa that goes to work there, thank you very much. These are great products. This is an R8 arbor on this, so it bolts right into the machine without an adapter. It's an R8 shank on it, in case I said adapter. Going to bring the bar down till I hit a hard stop on the quill. And I'm going to raise the table as the tool is spinning until I see a witness mark in one of the back 2 corners, or both of them, hopefully at the same time. At that point, I can raise the table to the required depth of cut. Okay, we're up against the stop. Here we go. I'll creep up on the dimension ever so slowly. There's not a whole lot of material left on this OD right here, so we're going to be careful bringing it in. .563 is the target dimension. Real time is about 6 minutes start to finish here. And let's see what we have on the mic. .563 and about 4/10. What it is, close enough. It's a 5/1000 tolerance. I'm going to go with it. Leave the table right on location, and we'll do the center hole features for the end and then flip the part. Next operation in line, 1/4 inch diameter counter bore, 1/4 inch deep. That's about 6 millimeters diameter, 6 millimeters deep. Doing this the same way as I backboard the diameter that you're looking at. I'm coming down to a hard stop with the quill, and I will raise the table after the witness mark. Now, a lot of you guys will have noticed and will comment that the bottom of these cutters is not necessarily flat. Well, if I'm looking to stick something in here that's 250 long, I need a complete cleanup, because if there's anything less than a complete cleanup, a 250 depth will not be achieved. So I need to clean it completely before I can start my 250 depth. Let's see if this makes sense. I'll do it a different way for you. Let's assume the top surface of this is the zero surface. I'm going to raise the table until I just scratch it with the end mill. You can see the witness mark right now. If I wanted this cutter to go down 250 deep, I could dial it in right now and go 250 deep. That's fine if you're going to make a channel, because the edges will erase the center. But in order for this pocket to be truly 250 deep, that little witness scratch has to consume the entire surface. Then the pocket's 250 deep. It'll be deeper on the edges, but it will accept a 250 mating feature. And that's how I'm going to do it. So I'll clean it up, 250 from there. That is my zero start point. Now you got to be careful about the draft on these castings. You can see the back face of that front. Let me lock that in for you. There you go. You can see the back face of that flange has got a severe draft on it, so you got to pick your poison and go with what you think is going to work. The dimensions on the print are all there. This 187 here that they've got illustrated right here, this 3/16 fractional, if you wanted to get technical, it is given from the face to where it cleans up. It is not given as the thickness of the top. So that's how I decided which way to go and where to start and how to finish this thing. But now that this diameter is cut, I have room for a small cutter to come in here and do this without nicking that diameter. Coincidentally, the distance across those flats is only 1/1000th of an inch difference, and it's less. So it technically could nick the diameter in those two spots. I'm going to try not to do that. Same setup I have right now, I'm going to flip it over and I'm going to put this hole in on the end, standing it up this way. These are not the same center lines. There's a 312 on one side and a 281 on the other. Do not get caught. This, when it says diameter through, that doesn't mean through the entire part. That means through to this pocket right here. Careful. A very slight setup change for the end hole. If you were watching the entire video, you will recall that this surface right here has about a 4/1000th taper to it. So that is not a good banking surface unless you want to crease in your part. So we're going to go with a trustworthy surface down here. And we're going to do it that way. Straightforward 125 diameter reamed hole right here, about 1.25 inches deep. Hopefully it comes out in the middle of that casting. Let's find out. Part is now inverted, banking on the thick sides that have not been relieved yet. It is indicated flat. I trammed between the jaws with an indicator to find my center line, and edge find the face, move in the distance of the hub because that's where all the dimensions are given from. It's time to put the slots in here. If all goes well, this first slot that's going in will reveal the 125 hole that I put in before. See if that happens. Secondary slide is being done with a 140 diameter end mill. That is about, what is that, 4.5 millimeters, 3.5 millimeters, 3.5 millimeters. Now you can see that the corners are undercut so that as I traverse with the wall thickness or to the dimension for the wall, when I hit the corner it doesn't chatter. That's chatter is caused by an increase in surface contact. So I'm going to plunge all four corners first and then go back and finish. Right now it's only rough. This will be the finish pass. First step in the next operation is to take a light dust cut on this surface right here to establish an overall height from this surface to the parallel registration surface. There's only maybe a half a millimeter to come off of here, but there's really no way to measure it when it's in place. So I'm going to have to take a cut, take it out, measure it, and put it back in the machine. Okay, forgive me, I jumped the gun on the final feature being the tapped hole. It was not. I need to create the rails on either side of this that are going to hold it down. Now, ideally, the best way to do this would be for it to be registering on the bottom surface, sitting upright, and you can track both sides. You could probably track most of the part strapped that way, but I chose not to do it. I'd rather use the vise. This is a piece of Delrin. It is very soft. It is not going to mar this, and I believe the pressure from the plastic is going to overcome the pressure from the cutter. So I'll flip-flop this piece as I go along, and let's see how it works out. I am going to cheat on the dimension that they give me because I just can't bring myself to hit that diameter. Let's do it. All the dials are zeroed at this point. I'm going to take the piece out, do a quick bench check. I need to check the width of this little tab right here and the distance from this surface to the mating surface on the other side. There will be a straight up adjustment after that. Finish cut should be easy. Let's take a final look at it. Surface on top is just about as wide as that casting, so I took the liberty of knocking the sharp corners off with a sweep. So nobody's going to get their fingers cut on that. I did stay about 2 thou away per side on these flat surfaces. I just couldn't bring the cutter down to hit that. It came out so nice I didn't want to see any blemishes on it. Single set screw in there. It looks off center, but it's really not. That's the draft you're seeing in the casting, forcing that to the one side. It is the print. Channels on the bottom. The print is tricky. You change up cutters a couple times based on the picture of the radiuses, the radii. For instance, that slat right there looks an awful lot like this slat right here. Looks like it. Anyway, there it is, guys. That is the end of this part. This is the end of this video. Thank you very much for tuning in. I enjoyed doing this. I look forward to seeing this thing clicking and popping. Joe Pye here at Advanced Innovations, wishing you well. I'm out.